So here is the question. A disk F of radius r moving on a perfectly smooth surface at a speed v undergoes an elastic collision with an identical stationary disk G. Find the velocity of the disk G after collision if the impact parameter is d as shown in the figure. And we've been given some options. So first we notice is one disk is at rest before the impact. Therefore, after the impact, its velocity has to be in the direction of the line joining the centers, which will be the line of impact. That is the line OP in the figure here. So let us assume that disk F moves upward with an angle of alpha 1, and G moves downward with an angle of alpha 2. Then the direction of G is the line of impact. So in this diagram, OP will be the line of impact. That's the direction of G, and in which G is moving, and so that angle POQ will be alpha 2. So in triangle OPQ, the angle POQ is alpha 2. OP is simply the sum of the two radii, 2r, and PQ is equal to the impact parameter given to us, d. It's simple to see that sine alpha 2 is d by 2r. Now the masses of both this are equal, so we can just use velocity vectors because the m terms will cancel out. So if we have a vector diagram for v1, v2, so that's v1 moving off at alpha 1, and there's v2 moving off at alpha 2. They should sum and give us v. Yeah, that's the whole idea of conservation of momentum in this case. So here we can see that v1 will be simply v cos alpha 1, and that's also v sine alpha 2. Yeah, and we got earlier that sine alpha 2 is d by 2r, so we get v1 is vd by 2r. v2 on the other hand, we can see that that is v cos alpha 2, and we got sine alpha 2 as d by 2r. So cos alpha 2 will be square root of 1 minus d squared by 4r squared. So we get v2 to be equal to v times square root of 1 minus d squared by 4r squared.